So this section is 5-2 continued. Got it? Continued. Whoops. Continued. Like that. And they start out with this corollary. And I would type this, but I don't know how to make F primes in my. Oh, I guess I could do that. I could. And I don't know how to spell corollary. Corllary. I could type it, couldn't I? Let's type it. Where was that thing? Is this it? Is this it? Text. Here we go. Right there. I can put it right there. And it says if, oh, look at this. F prime, oh, look at me go. If F prime of X, okay, equals G prime of X at each point on an interval I, don't I type that? Then there is a constant C such that f of C is equal to G of X plus f of X is equal to G of X plus, is that right? F of X, there's a constant C, so that f of X is equal to G of X plus C. Okay? So, what is this? Let's stretch it out a little bit and put it over here. Can I move that? There, look at that. Can I move this thing? I think if I get my pointer tool, I can move it up here. Okay? So, this is a corollary which kind of deals with the idea of an antiderivative. So, if f prime of x, and if you have two functions that have the same derivative, okay, what that means is that one original function is equal to the other original function plus some constant. Okay? For instance, if you have, for instance, say you have the function y equals 3x squared, and you have the function y equals 3x squared minus 5. What's y prime in this case? 6x. What's y prime in this case? 6x, right? What's the difference between this function and this function? The only difference is that they're the same, except there's a constant added to this function, right? And so from that corollary, which comes out of the mean value theorem, okay, you can come up with something called antiderivatives. Antiderivatives, which is basically going backwards. When we get to chapter 6, we'll start calling them integrals, okay? Indefinite integrals versus definite integrals, okay? But and we're not going to use the integral symbol yet until chapter 6, okay? So an antiderivative is it's fun to make integral symbols. An antiderivative is a function f of x, a function f of x is an antiderivative. Oh, I could use my typewriter. Antiderivative if f prime of x equals f of x for all x in the domain of f. Okay? So in other words, if I take the derivative of some function and I get I get f of x, then that f of x is an antiderivative of that function, okay? Excuse me, then f of x is an antiderivative of that.
So is there a difference between your capital F there and the lowercase f?
Yeah, this is, the original function is capital F, right? The derivative of that function is little f of x, just to kind of show that they're related, but they're not the same thing, okay? The derivative of big F is little f. Just to kind of show that they're different things that you're talking about, but they're related.
So which one is the antiderivative?
The antiderivative is a function is f of x, okay? The derivative of the antiderivative is f of x.
Which is the
Okay.
same thing as the
Is the same thing as the derivative of big f of x. So don't worry too much about the big versus the small. So let me just give you a example. Find the antiderivative. So wait, are you not clear on that, David?
I didn't know. It's really confusing.
Okay, so f of x, this is the antiderivative, okay? So if I take the derivative of the antiderivative, okay,
Yeah.
I get some function f of x, right? So usually what they'll give you is f of x, okay? So
Yeah.
what you're trying to find if they give you f of x
Okay.
is the function,
That is the derivative.
no, the function that when I take the derivative of this function, I want to get this function. So this would be the antiderivative, okay? So the antiderivative is the function that when I take its derivative, I get the original function.
So, like in the one that you actually wrote down numbers for, like the y and the y prime above there, like which one's
So-
the y equals 3x squared is the antiderivative because you take the derivative of that and you
This
put it
is
there.
an antiderivative.
Of 6x.
It's an antiderivative of 6. It's an antiderivative of 6x. So it's this.
Yeah, they
Okay.
both two, like the function that you take the derivative of and you get.
So you
Right.
can have there's an infinite amount of antiderivatives for each function.
Yeah, except there's a constant at the end. Okay? But I'm going to do a problem in a minute where you have a specific antiderivative. Okay? So can I do an example and I'll kind of show you, maybe it'll kind of explain it to you a little bit. So find the function, find a function f of x, okay? Find the function f of x whose derivative is sine of x, and whose graph goes through 0, 2. Okay? So this is where you kind of do it. So if the derivative, so I have this function y equals sine of x. What did I need to take the derivative of? What did I need to take the derivative of to have sine of x down here? Very good. Negative cosine of x. Yes?
Yeah.
So negative cosine of x, but I could have had anything over here plus some constant, right? So you always want to put this plus c at the end because I could take the derivative of negative cosine x plus 10, negative cosine x plus pi, negative cosine x plus 273, right? And I will still get the derivative being sine of x. Yes? You understand that? Okay? But this particular function, so we'll call this big f of x, right? Big f of x, this particular function goes through a specific point, okay? So it goes through this point 0, 2. So what I do with that is I plug in, this is y, I plug in 2 for y, and I plug in 0 for x, and I solve that equation to find specifically what function that is that has a derivative of sine of x. So what's a cosine of 0? 1. So you get -1, 2 equals -1 plus c, so c equals 3, right? And so then rewriting my equation, I would get big f of x equals equals negative cosine of x plus 3. Follow that? Yeah? Okay, so that is the specific function that goes through this point and whose derivative is sine of x. Okay? So that's its antiderivative. In general, to find an antiderivative, you always have to add a plus c at the end, because you don't know, exactly what that derivative is.
Because it goes away when you take the derivative.
Yeah, it goes away when you take the derivative. Okay, so I'm going to do an example that you'll like because it involves physics. All right, you like physics, right? First, I'm going to. So this is a good problem to show you that you don't always have the same antiderivative. So what you know, for the most part, is that objects falling have an acceleration of 9.8 meters per second squared, or 32 feet per second squared. Here we're talking about meters per second. Okay? Find the velocity and position functions falling from a height of 0 under each of the body falls from rest. Okay? How can it fall from a height of 0?
Because it's going under the ground.
I guess it just that they don't want to make things overly.
Yeah,
That was good.
And the body falls.
it was shocking.
Okay. So the first thing you know
Actually,
is that if you know 9.8 meters per second, if that's the acceleration. Can we stop all the chatter, please? Okay, I keep having to raise my voice to talk over you, okay? How would I find the velocity with respect to time? How would I find the velocity if I know the acceleration? What's the derivative
it's
of
the
velocity?
antiderivative.
Very good. So it's 9.8, and in this case, the variable is t plus c. Well, in the first case, so here we're doing the first case, flying freely from a height of 0 meters under each of the following conditions. The acceleration and the body falls from rest. So what is its initial velocity? 0. So 0 equals 9.8 t. What is its time at 0? 0. Okay, so that gives me that c equals 0. Right? So that is my so that's my velocity function. I don't need to do anything with that. I just leave it alone because c is 0. How do I find the position function from the velocity function? Divide by half. It's something
Divide by
squared,
2.
right? Yeah, so here you got to kind of think very good. So it'd be s of t. This has to be a t squared up here, right? If I'm taking, right? And so what would have to be here to make this, if I took the derivative of it, to make this into a 9.8? You understand that? Kind of what Braden said? 4.9. For 4.9 times 2, right, is 9.8. When you get to the integral chapter, we'll give you more specific ways to formulas to find integral. But still plus c, okay? And the first says accelerated and the body falls from rest. So what, and it also says from a height of 0, right? So what is its original? So if I plug in 0 in here, and I plug in its original position is 0, what do I get out? 0 for t. So s of t equals 4.9 4.9t squared. Now in the other case, so this is case A, right? In case B, the acceleration and the body is propelled downward with initial velocity of 1 meter per second, okay? And so in this case, you get the same velocity function, dt, when you take the antiderivative of 9.8, you get 9.8t, right, plus a constant. But in this case, what's the velocity? What goes in here? What's v of t? V of t is 1, okay? And it's positive 1 because this is talking about the velocity in a downward direction, okay? So it's not considered really negative velocity. It's just talking about from this starting point, its velocity is positive. So you're throwing it down with a velocity of 1. So 1 goes in there, 9.8t plus c. What's t at the start point? 0, right? So I get that. So I get that 1 equals c, right? So my velocity function in this case looks like 9.8t plus 1, right? Now I want my acceleration function, right? How do I find the antiderivative of this? Thank you. My position function. What's the antiderivative of this? 4.9 t squared again. What's the antiderivative of this? Plus t plus a constant. C. Plus c. Very good. Okay. In this case, again, as you're starting with, you're starting at time 0, okay? So s of t, your position at the start time is still 0. And it's still time 0 and time 0 plus c. So again, in this case, c is 0. And so your position function looks like exactly like 4.9 t squared plus t. And this might look familiar to some formulas that you've seen in physics, right? Okay, so and that's where they come from, taking the antiderivative of the acceleration and plugging in specific values and things like that. And so in this, I think in physics, don't they call this like h sub 0? They have an h sub 0 and this is v sub 0 or something over here. I'm not sure, but I forget, but we can figure that out. Okay? So that's how you do those types of problems. Yes, sir?
So if the problem said falling freely from a height of like 10.
Let's unpause for that very good question. He said if I started from a height of 0, right, then instead of plugging in 0 in here, I would plug in 10, right? If I started with a different speed or throwing it up in the air instead, if down is considered positive velocity, then up would be considered negative velocity in that case, and then you could figure out like the position at a certain point in time, stuff like that. They have one like that in your homework with a diagram.